Start recording. All right. Hi everyone and welcome to week 20.2. Today we're understanding some, boring things like patterns in JavaScript. Specifically, we'll discuss singleton pattern, and if we get time, we'll discuss another one called strategy pattern. We'll understand about backend state management. Harkirat, backend state management. We have understood front-end state management, recoil, redux. Why do you need to do state management in the backend? What are the times when you have to maintain state in the backend is what we'll discuss. A good example of this is real-time games like a chess game. And lastly, we'll understand about pub subs or publisher subscribers. We sort of did this in the past, but weren't able to implement it. We will try to implement a simple, ticker application today. By ticker, I mean, stock ticker that a bunch of people can subscribe to and get the current price of a Apple stock price or Google stock price, so on and so forth. That's the context for today. Let's get right into it. I think we should be done in an hour and a half at max, and then happy to review PRs after that, do something else. We'll go from there. Cool. What are we learning? We are learning about number one, stateful versus stateless backends. Very common interview question as well, and generally a good thing to know if you're going to scale applications eventually, because the way you scale a stateless application is very different from how you scale a stateful application. We'll understand state management in a backend application. In case you are maintaining or creating a stateful application, which you should avoid as much as possible, but in case you have to create it for a use case, how would you manage state in the backend? Then we'll understand about a common JavaScript pattern called the singleton pattern. Why is it used very often whenever you're maintaining state in the backend? And lastly, we'll understand pub subs, which is something that is pending from last week, and try to combine it with singleton pattern to create a pub sub manager class. This will be the high level of today. Let's get right into it. Let's start with the very first thing, which was stateful versus stateless backends. Some of you might already know this. Some of you might be able to guess based on the name. Okay, stateful versus stateless backends. Let's start with a diagram because it's just easier if you look at a diagram. Let's say you have a full stack application, and in the full stack application, you have a backend and then a bunch of users connecting to your backends. Notice it is a very big application. By very big, I mean you have a lot of scale. You have a lot of users. You only see 2 over here, but assume you have 1,000,000 users, which means you have to scale your HTTP servers. A single HTTP server isn't enough. You will need to have multiple HTTP servers. You will probably have a load balancer in front of them, which ignore for now, but a single server isn't enough. But if you have a simple HTTP backend, where does this backend store data? If I hit the backend and let's say this is a CMS like application and I ask, hey, can you give me all the courses I've purchased? Does this backend store it in memory or does it ask the database for it? And the answer is, Harkirat, this is all stored in the database. The backends are stateless. In most full stack applications, you try your best to keep the backends stateless. You don't store any data here. Why? Well, number one, backends are very auxiliary. They can die down anytime. They can come back up anytime. You scale them up, you scale them down. If you start to store data here, either in memory of the Node.js process, what do I mean when I say in memory? I mean a JavaScript variable called course purchases, or even if you store it in the file system here, if the server goes down, all the data goes down with it, which is why you persist data in a database. This guy stores no data. Then Harkirat, what is the goal of this guy? Why can't the UI directly talk to the Postgres database? Why do I have to talk to a backend, which then talks to a Postgres database? That is a great question. What is the purpose of a backend? The purpose of a backend is, our backend has full access to the Postgres database. Backend has full access. It can ask the database for anything. It needs to filter out. What do you have access to? If this is Harkirat, I can only get my course purchases. I can only get course videos for the courses I have access to. If I send a request, okay, give me course access to some course I haven't bought, the backend should block it. The backend should first check, does Harkirat own this course? And if they do, should they be given back the content? So that is the goal of a backend. Harkirat, seems like backend, can't we do this directly in the database? Yes, you can. Firebase is a very popular example of a system which is like, bro, I am the database and the user can directly connect to the database. And you can actually add some rules to make sure that the user is only able to access their own data and not someone else's data. So this architecture has been tried. Okay, you have a separate place where the database and the table is stored, the database is stored and the browser can directly talk to it. But generally, even with Firebase, people migrate over to Firebase, still keep a system in the middle. Here I will use Firebase as a database. I don't want my user to directly connect to Firebase. So the common architecture is stateless backends, stateful databases. Most of the times you will do this, but sometimes your backends need to store a state. Sometimes you need to make sure that backend I will have to store some data. What is a good example of this? In the CMS library, in the CMS repository, or generally when you go to app.redxdevs.com, all the courses that you see here are cached. All your purchases are cached here in memory. So whenever you hit a database, the first time we get your purchases and put them here, then for the next 5 minutes they stay here. Then we make them stale so that not every request of yours goes to the database. So that is one example of where we are storing state in memory. Should you do it? No, this is actually a very bad pattern. You should not store the end user's data from the Postgres database here. You can store it in Redis, which is something we discussed in the Redis class. Generally, you shouldn't store any data in memory. It will make your requests much faster. That is why, the first time you go here, it might take some time. Second time, it will, immediately get your purchases. This is your purchase. This is your purchase. Someone is logging in from my account. I feel I need to change my password. So that is one simple use case of when you want to store data in memory. But as I said, that's not a good pattern. So generally, Harkiyat, what is a good use case of storing data in memory? You said, okay, usually all servers should be stateless, and that is correct. Why? Because, even if you cache data here, let's say you have a bunch of backends. Harkirat asked, give me my courses. You went to the table, you got them here, you stored them in memory. And then the next request went to this server. Then you stored it in this server's memory, and the next request went here. There is no easy way to do distributed caching if the single server is where you're storing data in memory, which is why generally this is avoided. We have done it because we only have a single server. So it sort of works for us. Even we shouldn't do it. We should also store it in Redis. What are stateful servers? A lot of times your server needs to hold state. Good examples of this are, number one, as I said, we have an in-memory cache in the CMS repository. If you look at this class, it has a variable called in-memory database, where we sort of shove all the data that comes from the database and just keep it here for some 5 minutes, 10 minutes based on the thing that's being cached. If you look at the functions here, there is a set function and there is a get function. This stores some data in memory. This fetches that data from memory. You don't need a fancy class for this. You can just create a variable, right? You can just be like const cache equal to something and then, shove all of your keys here. But this is just a cleaner way to do in-memory caching. So that is one example of where we are storing data in memory and our servers become stateful. What is the other example? Storing the state of a game in a real-time game. For example, the thing about chess as a game is, okay, if you are playing chess, let's say this is your server and you have two people playing chess. This is person number 1 and this is person number 2. Let's say the person 1 sends a move, e4, e5, and then this move reaches the other person, and then the other person sends a move. They keep on doing this for 20 minutes, let's say. And let's say you don't want to maintain a state. You are like, nahin bro, I will be completely stateless. Harkirat said stateless is good. So this server will not hold any state. It will not store these moves in a variable. All of these will be put where? In a database. If you do this, every move that is coming by the user, I am storing in the database. Then the problem comes if this list becomes very long. Let's say there are 100 moves that have been made, and the user comes to your server and sends, whatever, e4, e3. You first have to validate this move. You have to make sure, is this a valid move? So what will you do? You will hit the server, give me the current state. You can also store the board state in the database. You don't necessarily only have to store the moves, but let's say you only store the moves. Then what will you do? You will ask the database, give me the current state of the board. The database will be like, acha ye lo. These are all the current moves that have been played. You will bring them in memory. You will calculate, is this a valid move? Acha, this is a valid move. Then you will store this in the database as well. and let the other party know. So on every move, you have to hit the database, get a huge list, bring it here, validate, and then let the other party know. This increases latency. So in a real-time game, a lot of times, most of the times, it makes sense to just store all of the moves in memory. So this is another example of where you would want to maintain state directly on the server. Okay, this is a game that needs to be very snappy, so I need to store all of this in memory. Another example is a Counter-Strike game. Let's say you have 100 people in an arena in a Counter-Strike game. You usually maintain that state directly in a variable on the server. What will you do? As the person moves around, let's say the person is moving around at 30 FPS, they are sending you, I moved up, I moved down, I moved left at 30 FPS, 30 frames per second, 30 times 1 second. Will you hit the database 30 times? Update the location. No, right? You don't want to keep doing that, which is why you store it in memory. The downside of storing in memory, there are a lot of them. Biggest one being if your server dies, the state dies with it. But you can get around them. We'll not discuss them here. I've discussed this in the past a little bit, but just wanted to share a bit. Okay, when do you store data in memory? Another one last example I will give is usually exchanges. Whenever you are creating an exchange, not whenever you are, but like most exchanges will store this order book in memory, which means it will be a variable over here. Okay, these are the bids and these are the asks. Harkirat, what are bids and asks? It's a finance jargon. Basically, the book that you see here, okay, this specific token I'll sell at this price and buy at this price, are usually stored in state. So that is where you have to use state. That is where you have to do state management on the backend. Your backend needs to, in a clean way, maintain these bids and asks or maintain the moves, so on and so forth. That is what stateful servers are. Let me quickly look at Q&A if there are any questions. None related to the class. Someone asked, how do you add cache eviction here? And the answer is we don't. The expiry is some 1 minute or so. So the data remains stale for 60 seconds. A lot of times I go to the admin dashboard and add a video and the video doesn't appear here for 60 seconds because the cache isn't invalidated. So we don't invalidate the cache very often. That is what stateful servers are. Okay? Servers that hold some variables. Servers that are not completely reliant on a database like this. Servers that a lot of times will put some data in the database, but also maintain a state over here of, whatever that specific application needs. For chess, it's a list of moves. For an exchange, it's an order book. For CMS, it's a bunch of cache data that we keep here. Question is, how can you do state management? What is the cleanest way to store data? Maybe before that, one more thing we should discuss is stickiness. One problem that comes when you have in-memory data is you have to make sure that the users who are interested in a specific room get connected to a specific server. I will repeat this. Let's say you are creating, we'll discuss two examples, a chess app or any real-time game or, an exchange, maybe 3 examples. Counter-Strike game. In all 3 of these, let's say you are playing chess. If 2 people are playing chess, then doesn't matter how many servers are there. Let's say you have 5 servers because you have a lot of scale. Doesn't matter how many servers are there. Let's say there's 1, 2, 3 servers. 2 people that are currently playing against each other. This is browser 1, this is browser 2. 2 people that are currently playing against each other need to be connected to the same server. Why, Harkirat? Because this is the server that has your moves, right? This is the server that has your moves, that has your current state. So you can't be like a second person, go here. This server doesn't know the moves of this specific, game, which is why you have to add stickiness. What is stickiness? It means here, if this ever dies, if this user ever disconnects or refreshes, make sure when they join back, they join the same server. You have to make sure there is some stickiness to the server that the user is joining. You can't join the user to a random server. That doesn't happen in a stateless server. In a stateless server, you scale ekdam aram se. Okay, you connect to whatever server you want. Doesn't matter. You send an HTTP request to whatever server you want. Servers anyways don't have any state. All of the servers are exactly the same. You can send a request to anyone. But in a stateful server, if user 1 and user 2 are connected in room 1, they need to be connected to the same server that's currently holding the state of room 1. Now you might say, Kirat, can I not store the state of room 1 in multiple places? Yes, you can. When you scale this application a lot, if you have a chess application which has 1 million users in room 1, 2 people playing and almost 1 million people, subscribing to the game in spectator mode, then you have to do this. You have to store the state of room 1 everywhere. But yeah, that's a scale that's not achieved very easily or at all a lot of times. So this architecture works. Cool. That is stateful servers. The same logic applies to if you are building an exchange. If you're building an exchange, the order book that I just showed you, this order book exists on a single server. Let's say, whatever this market is, Parcel USDC. So the Parcel USDC order book will exist on a server. Whenever I reach this page, I am being connected to that server. If I ever place an order, not directly am I telling the server I want to buy. Through some systems, I tell some server, which then forwards my request to a queue, which then gets picked by, this specific server. So it's not, in case of an exchange, it's not as easy as simply going here, but you get the idea. My request eventually reaches the server that has the current bids and the asks, or, the current state of this specific order book. Now, there are multiple order books here. This is just one market. You can also buy Solana. You can also buy another token. So each one of these run on different machines, or a lot of times on different cores on the same machines, but let's not go there. The point is, your request that's coming is going to go to a specific process that holds your state. Last example was Counter-Strike, sort of a game, or, a multiplayer game. There also you get the idea. Whenever you might have played Counter-Strike in hostel, you might have asked your friend, "Kya server bana de? Please create a server." And I would assume, I could totally be wrong here, I've not played Counter-Strike, but when I used to hear this, I always assumed, this is the server that's, storing the state and relaying their positions and all that jazz, for, lower latency. So they would create a server in the hostel and everyone would connect to that server to, play against each other. I would assume. I could be wrong. Maybe Counter-Strike does something else, but you get the idea. Cool. I think that's enough context about stateless and stateful. The only gotcha here is, you have to add stickiness. If 50 people in a hostel are playing Counter-Strike, they will all need to be connected to the same backend server. You cannot auto scale without stickiness. You can have another server where another 50 people are on another game, but these people who are on the same game need to be connected to the same server unless you scale a certain way, which we are not discussing right now. So you cannot do this. If these two people are currently playing against each other, they will be connected to the same server. Cool. That is enough examples of stateful versus stateless. And when you use stateless, most HTTP websites, you create an e-commerce website, you create Medium website, you create Paytm, stateless. Do not need to hold state. Most real-time games, stateful. That's usually the distinction of stateless versus stateful. Cool. Let's get into state in the JavaScript process. We understood stateful servers. We did not understand how can you store state. We have done state management on the front end. We understood about recoil. We understood about we not understand about Redux, but we understand that Redux is a library, recoil is a library, ZooStat is a library. That lets you do state management on the front end. What is state management in the front end? If this is your browser, it will have a bunch of variables. For example, if I am on LinkedIn, then these variables are all these posts that I have, my name, the number of notifications, all these things. These things are stored in my browser somewhere. My notifications are 20, and then my posts are an array of a bunch of posts. And this state is what's used to eventually render components. If you've gone through the recoil class, you understand that, hopefully. Even if you don't, it's fine. There are standard ways to do state management on the front end. And similarly, there are standard ways to do state management on the back end. How do you store these variables so they are easy to grab? Let's understand how do you do that on the back end. How/where can you store state in a JavaScript process? Can you do this? Let's say this is a chess game where a bunch of people are playing. Let's say there is a game going on between Harkirat and Raman. So I will store its state on the server in a object. Here game 1 is going on between Harkirat and Raman. These are their moves. And this is what the current board looks like. This is like a representation, a wrong representation of a board. You get the idea. And similarly, let's say another game is going on between Aarti and Samay. And then Aarti and Samay are playing the state are of those two guys is stored in the same object here. And let's say there is a spectator who's spectating on these guys' game. Spectator means just looking at the game, not actually playing. Then that person will also be connected to this same WebSocket server. So is this a good way to store state? You could argue yes. You are storing everything in a very big object. Whenever I play a move, this object dot game1 dot moves dot push, I will push my move here. I will update the current board and I will proceed. And similarly, if Aarti is playing, whenever she sends a request, the move is validated. If it is a good move, the move is also stored in the database. It is also updated over here. So this is a decentish way to store state. This is not bad, but there are better ways. On the front end, you can do everything, in state variables inside a use state if you're using React. But you try to use state management for better structuring, right? Same thing sort of applies here. Okay, you can do better state management on the backend. The state might be used by multiple files, not just one. So this following approach might not work. It might work actually. Let's look at this. Let's look at how more practically you would implement this, right? You would have a class, let's say a file called store.ts, which exports an array or an object called games, where you store, a bunch of games. Let's say initially, of course, this will be an empty object. Eventually you will add more things here. Then there will be an index.ts where there will be a WebSocket connection that's created or a WebSocket server that is created. Your user connects here, and anytime they send a message to create a new game, to create a new move, you update the store. Okay, a new game has been created. Please add a game 4 key over here. This is the white user, this is the black user. Or a certain move has been played. Please update the move for game 1, add another entry here, so on and so forth. So this is one approach. Let's say there is another file called logger.ts or database.ts, whose goal is every 5 minutes, I will take the state and put it in the database so that the database is in sync with the in-memory data. So what will this do? It will import the store from here. And then let's say every 2 seconds, I am currently logging it, but it will just store the same thing in the database. Do we understand this code by looking at it? Because if we do, then I won't write it. If we don't, then I will write this code locally and then we'll try to see how state management happens in a slightly more raw way. Eventually we'll make it better. But do we understand this by looking at it? We don't understand this by looking at it. So let's write it together. Let's try to create a simple server with some state, with a place where we're storing some data. Let me open Q&A also just to make sure how are we doing. How long the state of the game should be saved? Until the game is running. If one party wins, you clear the game. Is Redis being used in stateful? Not right now. You can use Redis, but what we're talking about is in-memory state. If this is your server, storing state directly over here. Okay, answer there. Why didn't we use Redis in CMS? No reason. I just wanted to avoid another service or to pay for another service. So I was like, put it in memory. I'm not going to scale to multiple users. Put it in memory. What is more cost efficient? Stateless is more cost efficient. I mean, debatable, but is more easy to maintain because the user can connect to any server. The user can connect to any server randomly. You don't need to add stickiness, and stickiness becomes very hard. So it's generally easier. You will try your best to keep your things as stateless as possible. Doesn't being stateless require constant polling to the database to know the other pair's moves and let them know my moves? It does. That is correct. If a new person joins your game, and if you don't have the state in memory, you will have to ask the database again, what is the current table, and return it to them. That is another very good reason you want to do statefulness in a chess game. Did not understand stickiness. Could you explain it again? Yes. Stickiness means if two people are joined, right? User 1 and user 2 in the same room, which means they are on the website, whatever chess.com, and they are currently playing against each other. That's what room means. What does a room mean? Two people are currently connected to the same room. So they're supposed to send data to each other, right? Person 1 sends data. I have moved this, it reaches person 2, and so on and so forth. Stickiness means since this room's state, the list of existing moves and the future moves are stored in this server, you need to make sure both of them are connected to the same server. You need to make sure if user 1 for some reason reloads their page, by mistake reloads, their internet disconnects. Whenever they rejoin, they need to connect to the same server. They cannot connect to some random server like you can in a stateless application. That is what stateful means. That is what stickiness means. Ki you are stuck with this server, bhai. As long as you are interested in room 1, as long as you're interested in the events of room 1, the room 1 state is here. You are stuck over here. That is what stickiness means. These guys are sort of stuck together, right? You cannot connect to another random server because this server won't even know anything about room 1. That is what stickiness means. Let me answer a few more questions, then I will proceed. State in streaming servers. So database or backend? What do you mean streaming servers? Do you mean video streaming servers? Do you mean data streaming servers? Is there any case where the state saved data should be pushed to the database? Not exactly. That is a good question. The question is, Harkirat, you are saying there is some in-memory database here. In-memory data. So this is your EC2 server, let's say. Harkirat, you are saying there is some in-memory variable here. For example, the current board of a specific game. The question someone asked is, do you have to update this in the database from time to time? Do you have to tell the database from time to time, yellow, this is what the board looks like? And the answer is not exactly. You don't update it from time to time. You very strictly update it. A move came here. Before I let the other party know, if the person 1 sends a move to the server, it should be stored in memory. It should also go to the database immediately. Because if the server dies, you need a track of all the moves that have happened. So you don't try to slowly push the state here. You aggressively push the state here. Every move that is getting relayed to the other person, you need to make sure the move has reached the database or will eventually reach the database. You should go through the last part of my chess video where I discuss this in a lot of detail. Redis is an in-memory database. It is faster, but it can't handle much requests. Therefore, we introduce the concept of statefulness and statelessness. Is that correct? No. Redis is fairly fast. It is an in-memory database. It is also very fast. Whenever you can, you should use Redis. Rarely should you use completely in-memory data stores unless you have a web application like a game. Even then, I would argue you can still cache this in Redis. So in-memory is something you should avoid as much as possible. Do we need to store the server ID also in the object for state management? Server ID, no. You just have to store the current boards or whatever the game logic is. You don't have to worry about server ID. Does a game like PUBG also use? Yes, I would argue they do. If there is a game like PUBG, all the 100 people that are currently playing against each other are connected to the same server. I would argue that. Could I be wrong? Could be. Their architecture could be different. But an application very similar to PUBG where I worked, which is gather.town, where you have a bunch of people moving around, not really shooting each other, but waving at each other, moving around, meeting each other, talking to each other. Here also same concept. You have a single server they basically had 50 servers, game-1.gather.town and game-2.gather.town, and this isn't any insider information. You could just open your network tab and see. So, anytime a new game was created, you would connect to one of these servers, whichever has the least load, let's say game 2. And then now everyone in the same room is connecting to game 2. So there is stickiness over there. So yeah, for a Counter-Strike, Gather Town, multiplayer game where you're moving around, you have a single server through which you relay information. In fact, here too, in case of Counter-Strike and Gather Town, you don't even need a database. You don't have to ever recreate, I was here, I moved, I emojified, right? There is no persistence that's needed. So, it becomes a very easy problem. You don't have to store any of the moves in a database, which you have to do in case of chess. So in case of Counter-Strike, it becomes much easier. Here, you don't even need a server. If a move comes, person says I moved up a bit, just relay this information to everyone. No need to store it in a database because you never need to recreate a room, right? You never go to Counter-Strike and replay your game. Maybe you do, I don't know. Maybe it's possible, but it definitely wasn't possible in Gather. I would argue probably isn't possible in there as well, in PUBG as well. Maybe it is, I don't know. But yeah, you get the idea. Cool. Let's write some code. Let me do a quick poll. How are we doing? Then we will proceed. Before we get into the code, we will write the code from scratch. But do we understand stateless, stateful servers? Why should you generally go for stateful? Avoid stateless as much as possible. We sort of do, like 84% we do. So let me do one more round of Q&A, very small one, like 2-minute round, then we'll proceed. If Redis is in memory, isn't it being used in stateful, or does it mean stateful just has variable? Redis is in memory. It is, you can technically say it's distributed state, right? It's similar to, if you use Redis, it's similar to you using a database. If this is server 1, this is server 2, this is server 3, all of them will connect to the same Redis. So you don't need stickiness anymore. There is if you are using Redis, your game state, if you are playing chess and this is user 1, your game state will be stored in Redis, which can be accessed by this server also, this server also, this server also. You don't need stickiness anymore. You need stickiness, or statefulness in our context today means state of a server, something that is not shared between multiple servers. If you use Redis, then all of them can sort of connect to the same Redis server and bring back the state in memory and do validations, things like these. Why can't we add logic to add stickiness in a stateless application? We can add logic to do that. That is exactly what happens, if I go to gather.town and I create a room like this, it first asks a server, okay, hey, ye room kahan hai? Where is this specific room? Does this room exist on game server 1? .gather.town, or does it exist on game 2.gather.town, so on and so forth. And then you get back the specific server you're supposed to connect to, you connect to that server. So there is stickiness, and it's very easy to implement in a multiplayer game or whatever your application is. Why not just use Redis as a database and clear cache once the game is over? You can do that. It will add a little more latency, but the other problem remains the same, because you will have to keep, that's not a bad architecture too. You can avoid in memory and then just store your games in Redis, and then you get them back, and then you don't need to worry about stickiness. People can be connected to separate servers, server 1 and another user in the same room. Let's say user 2 is connected to server 2, and then they're both playing the same game. They are both playing the same game, which means user 1 is in room 1 and user 2 is in room 2, and you don't store anything in memory. You store everything in Redis. Then what will happen whenever I play a move? If I play a move over here, let's say E3, E4, this move first reaches the server. The server gets the current state of the room from Redis. It doesn't have it in memory anymore. So it will ask Redis, what is the current board over here? Redis will return it. It will check, can I apply this move? Yes, I can. It will tell Redis, yellow, this move has been applied. It will also need to publish this to the other server. That will let the other party know this move has been played. So yes, this is a decent architecture. What is the downside? Very small downside is there will be some higher latency to get the moves in memory, which is fine. So this architecture also works. There is nothing bad in this architecture. You can do this, and this makes it stateless, so people can connect to other servers. People don't have to worry about connecting to the same server. Why can't, exactly. So someone asked, why can't we use a combination of Redis and WebSockets for state management? How do we clean the data when the user becomes inactive? Cleaning up data is a good question. If the user becomes inactive, if I die, the game state will remain here until the 10-minute timer is reached. And then, you have some process looking at, this game has been abandoned. It tells the database this game has been abandoned, and you remove it from memory. Whenever a game ends is when you can remove it from memory, because people will no longer be sending moves to you. People will just be asking for the history of the moves that you can get from the database. Great questions. Reshare screen. Let me do that. How to connect to the user to the same server to maintain stickiness? Yeah, there are various ways. That's a good question. If you use a load balancer, then also there is a way to do it. But generally the architecture that I've seen is, as I told like a few seconds ago, can you maintain a bunch of these servers? Whenever the user comes to your website, you first ask another service, which is usually called the router service, because it's routing you to the right server. You ask the router, hey, I want to connect to room 1. Can you please tell me the current server of room 1? The router checks, is someone else in room 1? Acha, no one is in room 1. Let me find the server that has the least CPU usage right now. Let's say it's this one. So it will assign room 1 to this room, and it will let the party know, please connect to server, whatever, backend 1.gather.town, and then, This guy will connect to backend1.gather.town. And then anytime another user comes and says, hey, I want to connect to room 1, it will ask the router. The router will be like, acha, room 1 is part of backend 1. So please connect to backend 1. This gets even more interesting and complicated when, let's say, the server goes down. Let's say backend 1 went down. Then the router needs to tell everyone, please connect to backend 2 now. Because, we have moved the state from backend 1 to backend 2. So these are like interesting challenges that come when you scale this or like create an application like this, because you have to worry about resiliency. If game 1 server goes down, the router tells everyone, hey, connect to this other server. So the router needs to make sure at every point it knows all the alive servers. If you want a little bit of a detour, this is how it happens in a bunch of applications. You have the router and you have a bunch of servers currently, game1.100xdevs.com. If you are creating a sticky architecture, then game2.100xdevs.com, and the router knows the health state of these guys. It knows that this is healthy, this is healthy. How does it know it? Every 10 seconds they tell the router, hey, I am healthy. This is called heart beating. This server heart beats every 10 seconds. Hey, I am alive. Hey, I am alive. Hey, I am alive. So the router knows I currently have 2 servers, game 1, game 2. And whenever users come, before they connect to any of the game servers, they first ask the router. They also maintain a WebSocket connection with the router. They ask, hey, I want to create a fresh room called room 1 for chess. Then the router will be like, I have 2 servers. What is your CPU usage? Because whenever they push the heartbeat, they will push their CPU usage with it. Currently I'm at 2% usage. I'm at 5% usage. So this guy knows, this is the least used server. It will let this guy know, please connect to game 1. That is the least used server right now. It will also maintain, room 1 is now connected to game 1. This guy will connect to this server and do its thing. And then eventually as more people join, they'll ask the router. Router will be like, you want room 1? Please connect to game 1. Second person will also connect to game 1, so on and so forth. That's how you maintain a fleet of servers and make sure the person connects to the right room. Was this clear? Little bit of a detour, but generally, can we proceed? Can we now proceed to writing some code that does what we've discussed a little bit right now? All right, greatish, cool. Let's write some code. Let's understand how you do state management. If you are going to now store some state in your server, how do you do it? And the answer is, as I said, this is the ugly approach. We can write this ugly approach, but let's just write the correct approach by creating some classes. So let's skip this slide for now, and let's understand how would you maintain state of a game in the backend server. Can you do something like this? Can you just store it in an object on the server? Yes, you can. But there are some downsides to this. The downside purely being, you directly interact with the data. You are like, whenever a user tells you a move, you have to move, you literally do moves.game1.moves.push. There is no easy function for you to call. You can't simply be like game1.add move or something like that. नहीं समझ आया, मुझे भी नहीं समझ आया. I think we will have to write everything. Let's write everything from scratch. Let's create a fresh Node.js project where we write ugly way to do state management and then slightly better way to do state management. So all the code is here. We can slowly try to sort of build upon it. But yeah, let's create 3 files. One called store.ts, one called index.ts, one called logger.ts that do very basic state management. So also take a break. Let's take a 7-minute break plus first, then we will proceed. I think, little dilly-dally of a class is going. So I want to make sure before we write code, let's take a break. And until then, I will look at Q&A. Take a breather. Let me also think a bit. Do we have to directly dive into singletons, or do we first write the ugly code? And we will restart at 7:50. Let me look at Q&A until then, starting from the bottom. Recap, please. That's a gate point. I should recap. Let's quickly do a recap of what we're learning. We're learning the very first thing about stateless versus stateful backends. That is where we spent a decent chunk of our time today, 40 minutes. Now we are going to dive into how do you do state management in backends. If you are going to store some data in your backend, which could be the chess game data, or if you're playing PUBG, then it could be the coordinates of a user, so on and so forth. How do you store it in JavaScript? Is there an easy way to store it, or should you just create a variable called, const games equal to empty array and just shove everything in there? Or is there a cleaner way to do something? Third, we'll understand the singleton pattern, which actually is the cleaner way to store data if you ever want to. This is one. The other way is you can also use Redux on the backend. I don't know how many of you know this, but Redux works not just in a front end. It's a state management framework. It works on the front end, also works on the backend. So you can either use singleton pattern the way we will discuss today, or you can use Redux on the backend for state management. And lastly, we will try to implement, I don't think we'll have time, but we'll try to implement pub subs plus singleton pattern today. Because that is another place where singleton comes into the picture. This is a common architecture used in many places. State management is one, but if you want to ever maintain pub subs is also a decent place where singletons come into the picture. This is what we are supposed to do today. What did we learn first? We learned about stateful versus stateless backends. Usually you strive for your backend to be stateless. What does stateless means? It means you will not store any in-memory variables. You will never store your moves over here in a chess game. You will never store your coordinates over here in a PUBG game. You will shove everything to a database, and your user will sort of hit your request. Let's say this is a chess game. The user will tell, hey, I want to make this move e4, e5. The backend will first call the Postgres database, bring the data in, validate, push the data, and then let the other party know, okay, hey, here is your move. So that is what stateless servers are. All HTTP servers, if you're creating an e-commerce website, if you're creating any website, mostly they'll be stateless. Stateless are very easy to scale. You can just bring up more machines, bring down more machines, and you're good to go. You don't have to worry about stickiness at all. But if you have a stateful server, if you're creating PUBG, then everyone who's currently in the same room needs to be connected to the same server, because this server stores their coordinates in memory. It stores them in a variable called coordinates of all users. Harkirat, why does it store it here? Why does it not store it in a database? The answer is the user is updating their location very frequently. Every second they're telling you, I moved up, I moved left, I moved right. If you start storing it in a database, how long will it take for everything to go to the database? Which is why you just avoid storing anything in the database. Everything is stored in variables over here. Question is, what is the cleanest way to store data in variables over here and not store it in the database? How do you do state management in TypeScript is what we are discussing next. Do we now understand a quick recap? I'm assuming I'm not doing another poll. I'll just look at Q&A and then we'll proceed. Is it illegal to do rate limiting attacks to get OTP in India? I don't think I can answer that question. I don't know. I don't know. Probably don't do anything stupid with it. But yeah. What happens when a server goes down and the router is aware of the server? How stickiness is maintained in this scenario? How does data move from one server to another? Great question. Again, these are things that you worry about in a very big application like Gather. But basically what happens is, let's say the server went down. Then it will stop heart beating to the router. It will stop telling the router, okay, hey, I'm healthy. So the router will realize after 10 seconds, I haven't received a heartbeat from this server. It means it has gone down. Who all were connected to Game 1 server? Let's say this guy was connected to Game 1 server. I killed the wrong server. You get the idea. Let's say this server went down. This person was connected to this server. The router came to know after 10 seconds, this server went down. So what will it do? It will push to these guys. Okay, please move over to Game 2. So all of these clients will move on to this other server. And as soon as the client moves here, it will tell the server, hey, I am part of, room 1. I am part of room 1. And then the server will bring the state of room 1 from DB over here, and you're good to go. For a chess game, for a Gather Town like game, for a PUBG like game, you don't need to. Yeah, then it becomes tricky, right? What happens in a PUBG like game and you're not storing any data in the database? In that case, this will just send their new coordinates, new location. Hey, this is where I am currently at. I am at position 1,2. And then, everyone will refresh their server, push their current state to the server. And then, the server will know, okay, acha, this person X1 is here, X2 is here, so on and so forth. So yeah, this is exactly what happened in Gather, at least while I was there. Okay, if a server went down, a new server came up, everyone pushed their state, I was here. The server becomes aware of this, and lets everyone know that this person is here, this person is here, and then continues as it would. Harkiyat, what happens if another person leaves? If another person leaves, this person leaves, right? Then the server doesn't need to know their location. Everyone else will know that they've gone, so on and so forth. All right. Can you give an example of a stateful application in an enterprise MNC setting? Rarely, if at all, you will see that. As I said, every company will strive towards statelessness. That's the thing that you aim for. We will try to avoid state as much as possible. So it mostly makes sense. It makes sense in every sort of application that I've usually worked on. So chess, real-time game, exchange. In all three of these, you have to store in memory data. But most applications, whatever, as I said, e-com website, or most enterprises don't need to worry about these things. All right, we're at 7:50, so I will proceed now here. Let's write some code. Let's write the ugly code first, and then we will write the better code. Okay? We are trying to create or simulate a chess-like game. We won't be writing the WebSocket logic for it. We'll be writing some simple dummy data and try to simulate what happens when a move happens. All right, cool. Let's open Visual Studio Code. Let's create a empty TypeScript project. So let me mkdir week 21 second live class. Let me open this in Visual Studio Code. I would urge you to do the same in case you want to code along. If not, that's fine as well. But yeah, I would urge you to code along if you have the time or if you feel like it, basically. Cool. Open an empty folder in Visual Studio Code. Going to give you guys 20 seconds to do it. Hoping this is, not hoping, this is simple, right? Create a fresh folder, open it in Visual Studio Code. Ten more seconds and then we will proceed. All right. Initialize an empty Node.js project here. What are the steps? npm init-y to initialize the package.json, npx tsc --init to initialize the tsconfig.json. Are all of these steps present somewhere? Yes, they are present on slide number 3 out of 6. So if you, maybe not. Yeah, the steps aren't mentioned here. The actual files are. So the steps are, again, npm init-y to initialize package.json, npx tsc --init to initialize tsconfig.json. What's the next step? Change the root dir to /src. Change the root dir to in tsconfig.json to /src. Change the out dir in tsconfig to /dist. Hoping that's straightforward. Nothing out of the ordinary here. Done this many times. Create a new folder called source. And here we will be writing all of our logic. Here we will be introducing a dummy chess-like game with in-memory state. Cool. Let's start with the first file. Call it index.ts. Start with the second file. Call it store.ts. That's good enough, but let's add a third one called logger.ts. So 3 files I've introduced. We'll be writing the code in all 3 of them very soon. But introduce 3 files: index.ts, logger.ts, store.ts. The thing to learn today is store.ts. How can you make this better and better than having a simple variable? How can you introduce classes? How can you introduce singleton pattern on top of classes is what we'll be aiming for in this class. But first we will start in a very simple in-memory variable. In store.ts is where we will export a variable. Let's say export const games equal to an empty array. The current list of games that I need to keep track of, my state will be stored in a single variable called games in a file called store.ts. I am not introducing Redux. I am not introducing singletons, which is something we will learn very soon. But for now, the most ugliest way to maintain state. It would be nice if you give it a type. We've understood TypeScript now. So I'm assuming you understand this code. Interface game, which can have, an ID, white player name, let's say, which is a string, black player name, which is a string, and then moves, which is a array of strings, let's say E4, E5, D4, D3, so on and so forth. So try to give it a type. Even if you don't give it, it's fine. You can always do an any array. So even this works. But generally, I think by this point, you should be able to give types to your arrays. This is the simple store.ts file that you can find in the slides as well, right here. The third one called store.ts. The interface is a little different. This one has an ID. Doesn't matter either way. Next step is creating a logger.ts. Let's say there is a file whose goal is to just log the state on the server, nothing more. Okay, by every 5 seconds, we should log the state for some reason. Forget what the reason is. So how will this run? It will be like, bro, import whatever games from ./store and then start an interval, set interval every 5 seconds console.log games. Does that make sense? The goal of this file is to just log games every 5 seconds, nothing else. Maybe what you can do is create a function that says start logger, and then inside that function do this, export this function from the logger.ts file. The reason I created a function is so you can import the function here and actually call it. Otherwise, unless you import this file, the file code won't run. So, the interval won't start. So just create a function out of it. If you want the code for this to copy paste, again, it is present here in logger.ts. You can copy this specific function. Lastly, index.ts, whose goal is simple. Here we need to simulate updating the state. We are not actually creating a chess game. We will eventually by the end of the class, not exactly, but like very close. But here we are just simulating. Here eventually users will come and they will update the state, right? They will push something to the games array. They will update the games array. They will push moves over there. So let's try to simulate that by doing a set interval games.push, a random game, let's say id math.random, and white player name some random name, black player name some, what's a good black person name? Not Bob, Denzel. And then moves, which is an empty array. Every 5 seconds, I'm going to push to this array. That is all that is happening. The other thing that it will do is start logger, it will import and just call the start logger function so that it starts logging the state. We have been able to sort of create an in-memory database, an in-memory store, which is nothing. These are all fancy words. In-memory database, variable. We have been able to create a simple array that we are using everywhere. The reason I'm stressing so much on this is because you don't usually do this. You don't usually store any data on your server. Your servers are stateless. Your servers are arrayless. You don't store anything on the server like this. We are doing it because we are playing a real-time game. So chalo for latency, or as I said, a bunch of applications need to do it. But the reason we are creating so much how out of this is because this is not usually done. State management is not usually done on the backend because there is no state to maintain on the backend. Those backend servers are stateless. Hopefully this is also straightforward. In the end, we have created 3 files. Index.ts is the file that we will run, which imports the game and the game's array and pushes to it every 5 seconds a random game. Can there be other things here? Yes, I could do a games of 0.moves.push. I can update the state just like I would in a real game. Let's not do it, but you get the idea. Here you will actually create a WebSocket server. If you look at the code base of chess, if you go to github.com/ if you look at the WebSocket server here, apps/ws/source/index.ts, what is the code here? There is a WebSocket server that is created. Ideally, you would do this, create a WebSocket server, catch all the events here, and then update the state, then update this games array, But we're just simulating the same thing by putting a set interval. Yeah, we don't want to create a WebSocket server that pushes in data. So let me just create an interval that is updating the state every few seconds. What happens here on the real chess website, there is a connection that happens. Someone connects to your WebSocket server and then they push you a bunch of events that somehow reach state. This is something we will explore by the end of the class a little bit, but this is the real thing. This is just a simulation of the same thing. Hopefully that's clear. Okay, we are simulating updating the game state. We are also logging it so we can see is it being updated every 5 seconds, so on and so forth. Let's see if this actually runs. Node dist/index.js. Let's see what gets logged after every 5 seconds. Firstly, an empty array got logged. Did I do a set timeout? There we go. Then a slightly bigger array got logged. Then an even bigger array got logged. So we were able to do state management on the backend. It's not the cleanest, but we are able to update a variable. You might argue, ये तो पता ही था. This is very simple. This तो we know. In fact, why did you go so fancy, Hakirat? You could have just done this const games equal to empty, just stored it in a top level file. Why did you create a separate file called store.ts? That's a good point. You can shove everything in the same file, like same file, and then have a global variable called games. That works as well. This is just slightly better structured if you have it in various files. Do we understand this code and how it is running and what it is doing? Of course, it's doing it in a dummy fashion. Every 5 seconds, it's updating state. In the real world, this would happen via WebSockets. But do we understand this much? If we do, then we will do slightly better state management using singletons. Pretty good. 85%. Good, not great, but I will proceed and take questions at the end. What is the problem in this approach? सब तो सही है. We have a separate file. Seems like we have some structure as well. Why do you have to do anything else, Akirat? This is good state management. Sort of true. The problem is, okay, whoever is updating the state has to do this. Your games or dot or whatever 0 dot moves dot push e4. They have to actually open the file and understand that this is an array. I need to update it. Wouldn't it be nice if they could do something like this? Game dot add move e4 and for this specific room 1. Wouldn't it be nice if we structured our state a little bit better? Arguable, you might say, nahi Harkirat, I like this better. But generally, it's a good idea to structure everything in a way that whoever is calling your function doesn't have to worry about, oh, this is an array, so I have to push it a certain way. They can simply call an add move function or an add game function and update the state without worrying about the internal logic of how state is maintained. The other benefit of creating a class like this is, okay, you can always update this class to, rather than storing it in file system, store it in Redis. Rather than storing it in Redis, store it in Postgres table. You can always update this class. You can create multiple versions of this class. So, initially you can do a Redis storage.addGame. Then you can do a local storage.addGame. Then if you want, you can do a, Postgres storage.addGame. So you can create multiple classes that have similar signatures. If you've heard of, extending classes, implementing classes. And that way, you can just change the class that you're sort of using rather than doing this. First you are doing games.push. Then if you have to ever change this to Redis, you will have to do a Redis.hset directly over here. It's just cleaner to do all of this in a class. So let's understand, how can you do state management in a class? How should I change store.ts to not export a variable, but export some class that let's say is called, game store, that exposes functions like add game and then, add move, so on and so forth, rather than worrying about, rather than doing a variable and pushes like this. That's what happens in the next slide. What is the problem? This will work, but a lot of times you need to attach functionality to state as well. Let's see if we can do that by creating a class called game manager and expose some functions on top. There is a call out here that says another very common way to store state. One is classes that we're discussing today. Other is you can also use Redux on the backend. You can use Redux in a backend application as well. It's not just a React only state management framework. Classes and singleton pattern. Let's see how things update if you introduce a class rather than a variable. Okay, this game.store.ts, I don't want it to export a variable now. It will export a class. Export class game manager, which will have a constructor and then have a add move function, game ID, string move, have the current games stored. So this dot games equal to empty array, and then whenever there is a move, you do a you find the game and then you do game dot moves dot push whatever the current move. So I wrote this a little too quickly. I will explain this in a moment. But yeah, add game. Let me add just one more thing. There you go. There you go. Rather than exporting a function, an array, I export a class. The class does have an array, but this is hidden from the world. This is an array it maintains. It has a this dot games, but it exposes functions like add move and add game, so that in index.ts, what can you do? You can be like const game manager equal to new game manager, where this is exported from here. And then rather than doing a games.push, you can simply be like games.add. This is my ID. Of course, you should probably send the first name and last name here as well, but okay, you get the idea. Game manager.add. Isn't this slightly cleaner way for you to update state? Yes, Arki, that seems a little more cleaner than doing a variable.push. So do we understand this by looking at it, or is this class a little jarring? What have I done? Let me repeat. I have created a class now. Rather than doing export const games equal to this, rather than doing this, this is what we were doing earlier. When you do this, then you have to have very ugly logic here. If you do this, you create a class which itself maintains the games. When you do a add game, it pushes it to the games. When you do a add move, it finds the right game with that specific ID and adds a move. You can similarly have a remove game function here, so on and so forth. Creating a game manager is slightly better or cleaner when using it in various places. So this game manager is a better way to do state management. Do we understand this? Why this is slightly cleaner, especially when calling the functions? How would logger.ts change? Harkirat, it would also be something like this. Game manager from store. Do you think this is right? If I do const game manager equal to new game manager and do a game manager dot whatever log over here, and let's say this has a function called log as well, which simply does a console.log this dot games. Is this right? Or is there a problem here? Can I do this? Or do I have to do something else? Can I recreate the instance of game manager here and call game manager.log and have a separate instance here in index.ts and do a game manager.add? No, this is a different object. This will keep adding it to this game manager, and the logger has its own game manager. It's similar to me doing, const games equal to empty array here and then doing a const games equal to empty array here. This will keep pushing to the games array. But this guy has a separate instance of games, which is why you can't reinitialize the game manager in both the places. If you do it, this logger will keep logging the empty moves array because nothing is being pushed here. I'm never doing a game manager.push for this game manager. I'm doing it for the one that exists in index.ts. Let's see if that is actually the case. If I start the process locally, tsc-b node/index.js, you will see the thing that gets logged every 5 seconds will always remain empty because I never added to this game manager instance. I only added to the one that exists in index.ts. How can you fix it? I'm assuming it's easy for you to understand how you can fix it, you can just export game manager from here and import it in logger.ts. That will create a circular dependency. Index.ts would depend here, logger.ts would depend here. So what you can do is you can export game manager in the store itself. Okay, yaar, this is the class, but I'm creating a single instance of game manager. This one right here. Everyone please use this. Don't create your own instances. And that way, import this here and import the same thing in logger.ts. Rather than reinitializing it, just import the single variable that this guy exports and then try. It'll just work now because you're using the same store everywhere. You're using the same instance of game manager everywhere. First time it's empty, but second time I would assume it works. Why is this undefined? Yeah, you get the idea. Do we understand this? How we have converted from a variable to, number one, we have converted to a class, and number two, we've exported a single instance of that class over here. Do we understand this? If we do, then we'll understand what are singletons and why they become useful in this case. %78%. Let me answer a few questions and then we will proceed. Maybe for the next 5 minutes, let me answer some questions. Then we will do the singleton pattern, which is, the even better approach over here, the third approach. What are we currently at? We're at the very first approach, this one right here. Sorry, this one, the bad approach over here. Slightly better approach. We have done bad approach and slightly better approach. We're supposed to do the singleton pattern, but before I go there, let me quickly open Q&A. Do you just want a recap or do you want something else? Use add quick recap. Game manager thing recap. Great. So let's recap game manager. What did I do initially? I said export games equal to empty array. I said, bhai, empty array hai. Everyone use this. Whoever wants to use it, please do a games.push or you do a games of i.moves.push. Call the API like this. This is what I am exposing. I am not going to write any logic for you. I am going to export a games array. You figure out how to push to it, how to pop from it. Then we said, why not create a cleaner thing? Why not create a class called game manager that we expose from here that itself keeps track. Okay, forget this. You can also do this. Export const games equal to empty array and then export a few functions. Export function create game that, just does a games.push and then export function add move, so on and so forth. You can do this. But if you know that there is some data and a bunch of functions that mutate that data, that is exactly what classes do, right? What are classes? You create an instance of a class, you call a bunch of methods on them to update the data to get the data. So rather than doing this, okay, you expose a clean API for others to update the store, just export a class. Okay, this class has an attribute called games. Initially, the games are set to an empty array, but if someone calls add moves, then I will add some data here or update this games variable. If someone calls add game, then I will, add the game here. I will add the move. And if someone calls log, I can log all the current games. Rather than exposing functions from here, I create a class and then expose the class over here. Harkiyat, why not create functions? Why not just write everything raw? It just gives you better structure, right? A class can be extended. If I create this class, Kalko, I can create another class called export class Redis game manager, which extends game manager and use all of these function signatures over here, override the function signatures. I can write implements some abstract class called game manager interface and then define a abstract class which has a method called add 3 methods. Then all of these Redis game manager and game manager can implement the game manager interface, so on and so forth. Like the benefits that classes give you. Do you need to create classes? No. But what benefits do they give you? Okay, if we created a game manager Then we can also create a Redis game manager in the future. If we, let's say, want to persist this data in Redis, we can also create a Postgres game manager. And then we can decide, should we use the in-memory game manager? Should we use the Postgres game manager? So on and so forth. So that is why it's a good idea to create a class rather than, export functions. You can totally export functions. You can totally export a variable over here. But creating a game manager class gives you sort of better structure to whoever is calling it. We export this game manager, create a new instance of it and export it. And everywhere I can simply call add game. If I change this in the future to, let's say, a Redis manager, all I have to do is export Redis manager. And now everyone that was importing it will now be able to put data in Redis rather than storing it in memory. That is why you want to create a class that other people can use rather than simply expose functions like, export function add move, which updates some games array over here. Do we understand why we have used a class over here now? Maybe that was a better approach to explain why we need classes, or what benefits do classes provide us. Great. 90% is beautiful. 87%. Cool. What is the problem in this approach? There is not a very big problem. There is one small flaw in this approach, that singletons take away. This is good enough. You don't really need singletons, but in a lot of code bases, you will see singletons and not understand what's happening, which is why I'm introducing it. But this is good enough. If you export game manager from here and everyone uses it, everyone is using the same instance of game manager. You don't have to worry about this guy will, create a new game manager instance and then, have a separate instance than the one that's exported from here. So this is good enough, but people can still create. There might be a new developer that comes in your team and then he's like, I'm going to create a new file here called db.ts that will take the state and put it in the database. And by mistake, he might do this const game manager equal to new game manager. And nothing complained. No, there is no red squigglies that you see here. We are allowing them to create a new instance, and then this guy might do whatever db dot, push, you get the idea. db dot push game manager, or, create game manager dot games. So there is scope for making a mistake here. Will people make mistake? Probably not. Whoever is the new developer that joins the team will look at index.ts and understand that I have to import the instance. They will simply import the instance over here and do whatever they're supposed to do. Game manager, db.create game manager.games. But they could do this. They might create a new instance. So can we somehow add a red squiggly here if someone tries to create a new instance? Can we enforce that only a single instance can be created? That is what singleton pattern lets you do. Singleton pattern says, if there is something you want initialized only once, then use the singleton pattern. By mistake also, people will not be able to create new instance of it. Right now, you could argue, Harkirat, we are creating a single instance. We are exporting this. And you might say, Harkirat, I will just do this. I will stop exporting game manager. So whoever wants to import, they can't even import this. So they won't be able to create a new instance. That is great. That is actually a great answer. You don't necessarily have to create singletons, but it's a common pattern you use. It provides you some benefits like enforcing no one will be able to call the constructor, which is why you learn about them. But is this good enough? It's good enough. Do we use singletons? Yes. Throughout our code bases, all of them, be it chess, CMS, maybe not daily code, but chess and CMS throughout use singletons. So let's understand this pattern. What do you mean by pattern? There are very common patterns you might have heard of, especially if you come from Java, or if you've done, that course in college. Adapter pattern, factory pattern. These are like standard ways to create classes most of the times. In JavaScript, you don't use many of them. The ones that you usually use are singletons or one thing called strategy pattern. Others are rarely used. You will understand singletons today. If we need, we can understand strategy pattern also, but not used as much as singletons. Singletons are the only ones that I've seen used. Let's see how can you enforce. No one can create this game manager class. How can you enforce no one can ever call new game manager? And the answer is just make the constructor private. If you make the constructor private, no one can call the constructor from outside, which means no one can do a new game manager like this. There is no way for you to create a new instance of the class. Great, Harkirat. You have made the constructor private, which means no one can call new game manager. But how will we create the very first instance? वो भी तो बनाना है. We have to create at least one instance, right? It is called singleton pattern, which means at least a single instance should be made. If you do this, not even a single instance can be made. Yes, a single instance can't be made from outside the class, but you can create an instance from inside the class. Let's see how. There is something called static variables and static methods. If you are from the Java world, you probably understand this. If you are not, let me explain. Static variables mean that whenever someone creates a new instance of game manager, right? Let's say this was not private, the constructor was public. Whenever someone created a new instance, a new games array was created, right? If I create two instances, then there is a games array for this guy. There is a games array for this guy. There are two separate games arrays. And if I ever, do a game manager one.add game, then it gets added to the first one. Basically, this becomes some value over here. If I do it on the second one, it gets added to the second one. So these attributes are associated to objects. These attributes are not associated to the class. I repeat, games as an attribute only comes into picture if you create a new game manager, if you create a new object out of it. Otherwise, this has no vajood, it never exists. Do we understand this? Do we understand how all of these attributes and all of these, I can never do, game manager dot add move. I have to call add move on an instance of it, on an object of the class. I can't call it directly on the class. Do we understand this? If we do, then we can understand static methods and static attributes as well. We understand this, sort of. 83% is good. If we understand this, what if I want to do a game manager dot what can you do on a game manager? Destroy, not destroy, but what is a good static method here? Game manager dot, I can't think of a good example over here. What would you want to do on the game manager? Clear, sort of. Yeah, let's say not exactly needed, but makes a lot of sense. But let's say you have to do this. Game manager dot clear, let's say, clears all the instances. Jitne bhi exist karte hain, it will clear all of them. So you don't want to call small game manager dot clear first and then game manager one dot clear and then dot two dot clear, so on and so forth. You want to create a global function that does this. How can you do it? You can define a static function over here. Add logic to clear everything. If you create a function that's static, it can be called directly on the class and not on an attribute. So if you ever want to do something globally, do this on game managers, not necessarily on game manager 1 or game manager 2. Do it in a more abstract sense, which means do it on the class and not on an object. You create static classes. Why am I introducing static methods? Why am I introducing static methods? Because we want to make sure a single instance is created. We are understanding the singleton pattern. So you can't ever create this yourself. You can never call new game manager if I make the constructor private. But you can expose a function called get singleton or get instance, which is static. That is why I'm introducing static methods, because if you cannot initialize a new object, how will you get the singleton object that is created? If the constructor itself is private, you cannot do this. How will you get the only one that we want to exist? The answer is by creating a static method called get instance. what will the get instance method do? It needs to create a single instance of game manager and return it. So it needs to do something like this. Const game manager equal to new game manager. Notice there are no red squigglies here. From inside the class, I can call new game manager. Even if the constructor is private, it can be called from inside the class. So game manager.getInstance is a static function that I can call. I call it, and then this instantiates a new game manager instance. This instantiates a new object of the class. Rather than doing what we were doing before, okay, at the end, I do export const game manager equal to new manager. I will do export const game manager equal to capital game manager dot get instance. And what is this get instance? It will basically, it needs to ensure, KR, if this gets called 100 times also, right, I will return the same instance. Even if a lot of people call this, by mistake a developer calls this again and again, I will make sure only one instance is created and I will return that instance. I will not recreate it again and again. How can it do it? By adding another attribute called, you can call it whatever you want, but instance is what it's commonly called. Here, I'm going to not just create a static method, but also create a static attribute. What does a static attribute mean? Again, something that is associated with the class and not an object. This is associated with an object, but this instance is static, which means it's associated with the class. And what is the type of this instance? It is the same class, which is why it gets a little confusing. Abhi tak confused ho gaye aap. Most people sort of get confused here. Okay, you know, private static instance of type game manager only. Why? Because this guy has to create a new instance, right? It can check, okay, does game manager.instance exist? And if it does, I will simply return game manager.instance. Else, I will initialize game manager.instance equal to new game manager and then return game manager.instance. This is actually the code that you write to create a singleton, but I can totally get if you don't understand it the first time. So let's look at a few other places where the same thing is created. Let's familiarize ourselves with it. Usually the thing to do is create a static attribute called instance, create a static method called getInstance. And now wherever you want to use game manager, no one can do this. Const game manager equal to new game manager, because the constructor of this guy is private. So everyone will have to use this, and doesn't matter if, you know, some random developer went to db.ts and did this. This will still return the single instance that exists. That is why it is called singleton. The question is, how does it ensure that a single instance is created over here in the getInstance function? And the answer is, it doesn't matter how many times you call it. You could call this function from 10 different places. It will check कि यार जो class थी, the class that existed, does it have an instance attribute? Harkirat, instance attribute on the class? Yes. It is a static attribute. Static attributes are associated directly with the class and not with an object of the class, which is why if it doesn't exist, if it already exists, it returns it. If it doesn't exist, it lazily creates one. Okay, game manager.instance equal to this and returns it. Do we understand this? Let me also share a few other places where this is done. Let's go to the CMS repository. And there you will see cache.ts. If you look at the cache.ts class, again, it has a private static instance of the same type, cache, and it has a private constructor. It has a get instance function. So this is like the common pattern you will see. Okay, there was a class, but to make sure it's singleton, to make sure you cannot create multiple objects of that class, you create a static instance that's private of the same type. Okay, instances of type, the same class, and then you make the constructor private and you expose a function called getInstance, which checks, is there an instance associated? This should ideally be, you know, whatever. This instance, yeah, this should be cache.instance, but you get the idea. Does it exist? If it does, I mean, this works as well. This over here means the class and not an object, but you can replace this with cache as well. Is there an instance? If there isn't, then you create a new one, and either way you return it. Another place where you will see this also feels jarring, is socket manager.ts over here. There is a class called socket manager. It has a private static instance which is of the same type called socket manager. I should make the constructor private. It isn't right now. And it has a static get instance function which checks, is there an instance of this specific class? Does this static instance exist? If it does, it returns it. If not, it initializes a new one and returns that. So it doesn't matter how many times it's called. Only once will this code run. Only once will you generate a new instance of that class. Do we understand singletons? Considering we looked at 3 code bases now, which as you can see use them pretty similarly. Wow, surprisingly 91%. I did not expect that. Great. So फिर तो भाई, let's just finish this code very quickly, which is nothing. Yeah, pretty much you have this game manager. You don't have to export this anymore. You can simply in index.ts go game manager dot get instance dot add game, and then the same thing in store.ts, sorry, db dot or whatever, logger.ts. Okay, just import this and do this. You will, if you look at all of these code bases that I was just showing you, you will see from time to time, we call this. For example, here I'm doing socket manager.getInstance.broadcast, socket manager.getInstance.remove user, so on and so forth. Great. So if we understand this, then should we do some pub subs, or should we take a pause? Because that's what the next thing is, pub subs plus singleton. This thing is basically pretty interesting. We'll be creating a system like this, where you have a bunch of WebSocket servers, let's say, and you have a pub sub, and you have 1 million users over here. 1 million users have created WebSocket connections to all of these randomly. First person says, I am interested in Apple stock. Let's say your front end is an application that looks like this, where you see all of these prices. Yeah, this is the current price of this cryptocurrency. This is the current price of this cryptocurrency. So the users will tell you, I am interested in Apple stock. I am interested in Google stock price. And the user can randomly connect to any of your servers. These servers now don't have state. They are completely stateless. So the user can connect to any random one. ऐसा नहीं है कि if 2 people are interested in Apple, they will have to connect to the same server. No, they can connect to a random one. And now some other external service is going to tell you Apple price is 200.2. And this pub sub needs to broadcast it to the right servers. If this person was interested in Apple stock, then this server needs to tell the pub sub, okay, yaar, I am interested in the Apple stock. Please give me the update. And similarly, if this person, then this server also. If this person leaves, then this server needs to tell the pub sub, okay, bro, I'm no longer interested. Don't forward me any more Apple stocks updates. This is what we are supposed to build, but happy to do it offline as well. And answer questions right now. I'm open either way. Should we proceed to the pub sub section next? Yes or no? Oh boy. %56% yes, 44% no, which is bang in the middle. So let me think, but I think if 56% wants it, I mean the majority wins, but there is let's do it. Let's do it in 15-20 minutes. I think that's anyways enough to do this, because we won't be creating any WebSockets connections over here. We'll be creating this. The benefit of learning this is, okay, we need to implement this in chess very soon. This is how you scale WebSocket servers. Okay, if you want person 1 who is in room 1 connects here and person 2 in room 2 connects here, even if they're in the same game, then you need a pub sub to broadcast data. I made a E4 E5 move. I validated the E4 E5 move. I send it to the pub sub. Pub sub forwards it to the other server which is interested in it. If the chess game has 1 million users, then you'll have 1 million users here. All of them will connect to various servers. The pub sub needs to broadcast events of that room to every server. So the reason I wanted to introduce this architecture was I will introduce it enough, and then if you want, you can try to implement this in the chess repository. Right now the chess repository does not have pub sub. It has sticky WebSocket connections. But if you want to scale sticky WebSocket connections, which if you want to know the architecture for that, then just go here. just go here to the last section where scaling the system, this last 20 minutes or so. I discussed the architecture here. I'm going to discuss some implementation right now. And if you want to code it yourself, you should. If you code this yourself, I can almost guarantee that, you'll be out of tutorial hell if you code it yourself. The first time this happened for me was when I wrote a multiplayer Flappy Bird game where I wrote it myself. I understood the architecture, I understood some code, but wrote this myself. So if you want to, if you are stuck in that stage, I think I will give enough knowledge to be able to do this yourself, then try it yourself. Cool. With that context, let's go into pub sub and singletons. Before that, what is pub subs? We discussed this a little bit in the past, but let me quickly share what is a pub sub. It stands for publisher subscriber, which, as the name suggests, is something that lets backend servers or even front ends, but like most probably you will be using this in backends. It lets backend servers talk to each other. How do they talk to each other? If one backend server wants to let other backend server know something, which, as I said, in a chess game could be, the person one is over here. He's playing a game with person two. Let's say both person one and person two that are playing the game are on the same server. But there is a spectator. There is someone who's looking at the game from the side and spectating on the game. That person is, let's say, on this server. Then whenever a move is made, it needs to reach this server, right? It needs to reach this user, which means it needs to reach this server, which is where you need servers to talk to each other. Servers need to talk to each other. And how can they talk to each other? Harkirat, I will create an HTTP request from here to here. You can do that. But what if there is another person over here on, the other server? Harkirat, I will create 2 HTTP requests. What if there are 100 servers? You cannot create 100 HTTP requests, which is why, you can create it, but don't. That's bad architecture. So what can this guy do? Whenever an E4, E5 move comes or whatever move comes, it can just tell a pub sub, I am publishing an event on room 1 that this move has happened over there. E4, E5. And what does the pub sub need to do? It needs to be like, who was subscribed to room 1? And of course, if P3 is here, even before this published happened, this person will be like, I am interested in all events of room 1. So since this person says I'm interested in all events of room 1, the pub sub will get this message and forward it to this server, which will forward it to the end user. That is one common use case of pub subs for backends to talk to each other. What is another common use case? What are we building? A stock ticker application. Okay, people can be like, hey, I am interested in the Apple stock. And this person can also be like, I'm interested in the current price of Apple. So wherever your service gets this Apple price from, which could be, NSE, not NSE, you get the idea, NYSE, whatever is the New York Stock Exchange, you get the price from here. You can totally, be like, yeah, this is a backend server of mine. And this backend server will, send HTTP requests to whoever is interested. You can do that. But again, a better architecture is a pub sub, which was just made for this use case. Whoever is interested in the Apple price, please subscribe. Tell me or let me know you are subscribed to the Apple stock. And then whenever there is an update from New York Stock Exchange for the Apple stock, I will publish to the respective servers who can then take the responsibility of forwarding it to the end user. Do we understand what a pub sub is? Because if we do, then we can write some code and, do we understand what pub sub is? Build a system like this. Sort of. Great. 85%. Good, not great, but we'll take questions at the end. So let's understand how can you create a pub sub. Create a pub sub manager class, a singleton class called pub sub manager. Kirat, why can you do this without a singleton class? You can probably, again, as I said, you can create it. You can just create a function called that. You can just export functions called, publish and subscribe. But it's generally a good idea to create a class out of it. So we're going to create a class called pub sub manager. It will keep track of what all stocks are user on this server interested in. This Node.js process will keep track of here people are interested in Apple stock. 5 people are interested in Apple stock. So I will subscribe to Apple. If all 5 of them left, I will unsubscribe from Apple stock. So that is what this specific class needs to handle. It needs to expose simple functions. Add user to stock, remove user from stock, remove user from server, things like these. It needs to expose simple functions and maintain the publisher subscriber logic. Tell the publisher subscriber, hey, subscribe, hey, unsubscribe, things like these. It relays the events to the right sockets whenever an event is received. Whenever an Apple stock update comes here, it will know, okay, Harkirat wanted it, let me forward it to Harkirat. So that is what this class needs to do. Let's look at how you write the code for it. Number one, you need to start a pub sub locally. There are many popular pub subs. Redis is the one that we'll be using. So try to run Redis locally. I'm going to be a little fast. So, if you don't have Docker now, you don't have the time. If you do have Docker, try running Redis locally by running this command. How does this start Redis Harkirat? We've discussed this many times. This is, an actionable way to start any service locally by using Docker. The way the process that we are running today is Redis. Docker run in detached mode with this port mapping Redis. If I run Docker PS, I will see there's a Redis instance running. Let me simulate some publisher subscribes. Just show how PubSub works in Redis. There are steps here, but you don't have to do this. Let me open two terminals side by side and connect to Redis in both of them. I have connected to the Redis server in two terminals, or Redis container in two terminals. I can run redis-cli in both of them. And here I can publish an event to publish an event. I can write a command to subscribe to, let's say, Apple stock. Subscribe to Apple stock. Any update comes on Apple, please send it to me. Right now I'm doing it in a terminal. Eventually we'll do it in a Node.js process. And let's say I do a publish Apple 200.2. That's the current price. As you can see, whenever I publish, it reaches here. Let me start a third terminal where also I'm doing the same thing. I'm subscribed to APPL. Now there are two subscribers to the Apple stock. I publish it once, it reaches both the places. Of course, this will eventually be in a Node.js process, but hopefully this is clear how the Redis PubSub works. Some process can publish, other processes can subscribe to it. Harkirat, whatever random person publishes to it, cannot, right? You own this server, you own this whatever server that's getting an update from NYSE, you own these servers. Only these servers have credentials to your Redis. So no random person can publish to your Redis server or to your PubSub. Only this server that's connected to New York Stock Exchange can publish. Only these servers that are connected to your users can subscribe. So no random person can subscribe to it. And this is how you sort of do simple PubSubs in Redis. Now we just need to convert it to a Node.js process. Cool. So let's stop all the publishing and subscribing. You can create a new project as well. You can just get rid of all the functions here and use the same project. Let me get rid of store.ts. Let me get rid of db.ts. What are we supposed to implement? What does the slide say? You are supposed to implement a pub sub manager class. So let's write that logic. Let's create a fresh file called pub-sub-manager.ts, export class pub-sub-manager. They said it needs to be a singleton. Even if it's not a singleton, it's fine. But let me make it a singleton. We have learned something new. Let's implement it. Private constructor. This dot don't need to do any subscribers. So never mind. We'll get there. Private static instance, which is of type pub-sub manager. Instance is of the same type, and then public function called getInstance, which is static, which does what? If pub-sub manager.instance doesn't exist, then initializes it and then returns it. Makes sure that whoever is calling pub-sub manager.getInstance, doesn't matter how many times this gets called, only one instance is created. Given that we have this, what does this need to do? It needs to keep track of who all users are subscribed to Apple stock, who all users are subscribed to Google stock, who all users are leaving right now. All of these functions it needs to expose. It needs to expose a function called add user to stock, user ID, and stock ID or stock ticker. And then maybe, if I'm on this website, If I'm on this page, I will tell the server, hey, I'm subscribed to everyone. If I move to page 2 over here, let's say, then I will say unsubscribe from all of these, subscribe to the ones on page 2, right? So there should be another function called remove user from stock. Okay, this user is no longer interested in the Apple stock ticker. They are now interested in some other ticker, right? That's it. This class needs to make sure, maybe another function is forward message to user, which needs to be called whenever a stock update comes from New York Stock Exchange. Okay, yeah, this is the new price for this stock ticker. It needs to forward it to this specific user. This class needs to sort of call this function itself. Can you implement this? I can implement this. And there is a solution here as well. But would you like to implement this yourself while I answer some questions? In the end, I'm happy to, pretty much build something like this. Let me not take you through this. Try to implement it yourself. The one thing I will share a little with you is, you created a Redis client. Like this is how you do publisher subscribers in Node.js. If you want to do a Redis PubSub, you have to create an instance of Redis client that you can do by calling create client. We did this in the Redis class, so this isn't new if you've gone through the Redis class, but you create a new instance of the Redis client. Whenever the user subscribes, what will you do? You will sort of push this to an array. Okay, this specific stock now has this user ID interested in it. And if the number of subscriptions for that stock is 1, which means this is the first person who is interested in the Apple stock, you will do a this.redis client.subscribe. यार पहला बंदा आ गया, first person is here who is interested in the Apple stock. So you will subscribe to all the events on Apple stock. And what happens when a user unsubscribes? We first of all remove that user from this sort of array that we have, and then we check, are the number of users interested in this stock 0? Has every user who is interested in Apple stock left? And if they have, we tell the Redis client to unsubscribe. Here we don't need any more Apple stock updates. The WebSocket server will tell the PubSub I no longer need Apple updates. All of my users who were interested in Apple's updates have gone. They have told me they don't need Apple updates anymore. That is what this unsubscribe function does. And lastly, there's a function called handle message, which if you see gets called here. This.redis client.subscribe stock. And then there is a callback. Anytime there is an update on the Apple stock, control will reach here. You call handle message, which iterates over all the subscriptions and currently only logs. Okay, send this message to the user. Okay, Apple price is updated. But eventually you'll do a socket.emit over here. You'll tell the end user, okay, yellow, the stock has updated to 200.2. So this is the code. I would urge you to write it yourself. It's not too difficult to write. And then I've written some random code in index.ts to simulate calling user subscribe, and you can call user unsubscribe and see if the logs are working, if you are, actually subscribing or not, and then try to send, like publish an event from here and see, does it reach the Node.js process, so on and so forth. Try to code it yourself. If not, I'm happy to cover it in an offline video. But if you have reached this far, if you understood this much, if you understood how to write classes, which 90% of you did, and if you understood this much, okay, this is how you create a client. You have to connect it. And then if you call Redis client.subscribe, it will subscribe to that specific ticker. If you called unsubscribe, then it will unsubscribe from that specific ticker. If you understand this much API, you should write this sort of class yourself. All right. Time for some questions. How was the class? Did we understand most of the things, everything? Did we not understand anything? How was the class? Good, yes or no? And I think after this, we just have to sort of focus a little. 85% is like good, not great. But again, Q&A time. So happy to take questions. And also happy to, explain this more detail in an offline video. But let's open chat and answer some questions. If you understood everything, feel free to, call it. And I will see you guys next week and in some offline videos this week. I'm opening chat. All right. Let's see. Why do you say that stateless applications act as a redundancy? Redundancy, since we are communicating with the database eventually. Why did you say that stateless applications act as a redundancy since we are communicating with the database eventually? I guess your question is, okay, why did I say कि यार this is a stateless application. Here, though, if a user comes and sends you a chess update of e4, e5, then it needs to reach the database. And it will reach the database, take some time, and only then can you tell the user कि अच्छा e4, e5 happened. So the latency is really high. Versus if I was storing it in memory, then it was really fast. But I also said कि either way you have to store it in the database. Even if you have it in memory, eventually it will store in the database. So I guess your question is, हरकीरत फिर तो benefit ही क्या हुआ? If you are saying even in a stateful server, it needs to reach the database, how is that any beneficial in latency? It will still have to hit the database. And the answer is, if you have a stateful server, you don't necessarily have to hit the database. You can quickly throw it in a queue. You don't necessarily have to wait for it to reach Postgres. You can throw it in a queue. You can throw it in a Redis queue, let's say, which is like much faster, and move along. Eventually, the Redis queue can propagate to the database. This is again something I covered in the last part of the chess video. The benefit that this provides is that you don't immediately have to send it to a database. Throw it in a queue, and as long as it reaches the queue, move along. Eventually, you can send bulk updates from the queue to the database, which is why this will be slightly faster, even though eventually this also has to propagate to the database. Will the router service have its own database, or will it maintain data in memory? Good question. And gather it through everything in Redis. You can have it in a database, doesn't matter. You can maintain the health status in a database. You don't need it you can't keep it in memory because the routers, eventually you will have multiple routers. You cannot have a single router, right? You need to have multiple routers because you might have so much traffic, a single router cannot handle the routing, which is why, they need to share state somehow. You can store it in Redis, you can store it in a Postgres database, doesn't matter. But yeah, there will be someplace else where this data is stored. Are singletons only used in stateful applications? No, this application isn't stateful. If you look at, well, it sort of is. If you look at this, PubSub manager, singletons are used when you want to create a single instance of something. Don't you remember this? We discussed the Prisma client. This is also singleton, by the way. If you look at Prisma / where is it? CMS source db.ts db / index.ts. What is happening here if you look at it? When you run Prisma with Next.js, whenever Next.js hot reloads, this code runs from top to bottom again. If you run this code from top to bottom again and you reinitialize, this Prisma client, you run out of the number of connections to Prisma client. We have gone through this in Prisma. We have also read this in, Prisma with Next.js best practices. Here also singleton is only being created. If you look at the code, first of all, this comes from here. Okay, this is the code base that tells you, okay, please, create a singleton. What does it say here? Const Prisma client singleton. This also makes sure, if you look at this code, pretty much does the same thing. Okay, if you are not in production mode, it sets this Prisma instance on a global variable. And then if there are hot reloads, it uses the existing variable. If you're in dev mode, if you're in production, then do whatever. But if you're in dev mode, as you hot reload, this code runs again and again. If you simply did this, you create a bunch of Prisma client connections, and then your DB runs out of connections. So you create a singleton, and then, if you're not in production, you're in dev mode. If the global for Prisma.prisma already exists, you return that. If it doesn't exist, you call this function, which sort of returns it, and then you eventually set it over here. So yeah, this is another use case where you want to use singletons. Whenever you want to minimize the number of database connections you're making, you will, put that in a singleton so that even if multiple places people are trying to connect to the database, they are reusing that single connection. That is another important sort of PR review. YouTube does like this in subs. YouTube does like this in subs, as in? Did not understand that. Off topic question. I haven't practiced JavaScript, but I have built projects watching tutorials in JavaScript. Should I build in JavaScript? Yeah, build like some Canvas project. They're very easy to build. Don't build React projects yet, but simple front ends using Canvas are a sort of great thing to build if you're just learning JavaScript. Why actually video was uploaded very late? It was uploaded on CMS. Long story short is the video is very big. It was 6 GB because this time long story short, I rendered it in HD. It was 6 GB. It did not transcode the whole day. That's the long answer. So I'll try to upload today also the slightly low quality version. So when you export in Premiere Pro, it gives you a few versions. Yesterday I tried the high quality version, and then it was some 8 GB and took a long time to transcode. मैं जावा छोड़ के जावास्क्रिप्ट में आया था. आपने फिर बता दिया. The good thing is that you doesn't have it too often. Like singletons, classes, khatam. Little bit of extend. Why are we building? We are building an open source lead code version with added flavor of chess like competition. Users can match make with random users to win increased rating. Your thoughts on this? Yeah, we will eventually add ratings and everything there. But like, where does lead code come into the picture? We are building an open source lead code version with added flavor of chess like competition. You can you're saying one-on-one lead code matches? I don't know about that, but we can see. Doesn't sound too bad actually. Create a puzzle, but you'll have to create so many puzzles, otherwise they'll be recreated. Like let two people challenge each other on a puzzle, something like that. I don't know. It sounds pretty interesting. You are building this. Okay, sorry. We are building an open source lead code version with another flavor like chess like competition. You can match make with okay, you are making this. So your question is basic architecture to follow. So number one, you will have to build a code execution engine. You can use Judge Zero, a bunch of open source APIs, free APIs. You can use them or build it in-house. That's the first part you need to implement. Second part is simple, just like any other competition. Two people come, two people join. Both of them run. Whoever runs the first code or whoever submits the first that gets an accepted sort of wins, and then you run your rating logic based on that's the same in Codeforces in chess. So whatever rating logic you want to follow. Topic related questions. Let's open that. Can you explain another common pattern like singleton? So as I said, there is one called strategy pattern that pretty much does this. Let's say you have this website, whatever, harkirat.classx.co.in, and currently you are accepting payments via Razorpay. But let's say Razorpay goes down one day and you need to switch from Razorpay to Paytm or from Paytm to Stripe. So here you can use something called a strategy pattern, which pretty much, also has a class like payments class over here and has a function called switch strategy that you can call. So, you can have some part of your code base that keeps polling Razorpay for status. And if Razorpay ever goes down, all it has to do is call switch strategy with, Paytm over here. And then all the API calls will now start to go to Paytm. And if you call the same function with Stripe, all the requests will start to go to. So in a single function call or a single class call, you can, switch your payment provider. Another place where this is used is, a lot of times if you're building a website like, Zoom, not Zoom exactly, but a website like Zoom. You're not building Zoom, you're building a website like Zoom. So you depend on external APIs like LiveKit or Twilio or, what's another good one? There are like a bunch of them. Let's say Agora. Yeah, there you go. Agora. So here also, you will first, let's say your video communication is happening via LiveKit, but some problem happens in LiveKit. You just call a single function, switches over to Twilio. Call a single function, switches over to Agora. So yeah, that's another common sort of JavaScript pattern. Read about just Google strategy pattern. It will show you, this is how it works. And then, go from there. If you need a class, let me know. Discord is stateless or stateful? I would assume it's stateless. I don't know. But the scale that they have, a single person, in a single room, there can be a million users. A single server cannot handle it. If a single server cannot handle a million users, or your scale, then you cannot be stateful. You have to be stateless. High level overview of Google Meet versus Zoom. Like the architecture, there is versus Zoom. Ka kya matlab hai? Similarity is all around, bro. There's no difference in the architecture. They're the same, right? Is there any Zoom provides you 10 different extra features like, whiteboards, streaming to YouTube directly from Zoom, things like these. But the core offering, Google Meet call between two people, a Zoom call between two people, is always, the architecture is the same. There's no difference. There might be differences, of course. Like companies are different, but yeah, they both use an SFU architecture if you've heard of it. When to use WebRTC versus WebSockets? Pretty common question. Simple answer is if you need if you need reliability, if you need every message to go from one place to another, for example, chess, then you use WebSockets. If you don't worry about every event reaching the other place, which means, Counter-Strike game, if you're moving around at 30 FPS and a few events get missed, it's fine as long as the last event reaches. So there you use WebRTC. Why do we need to use WebSockets in the merchant apps? Why can't we like user app? Because in the merchant app, we have one extra feature. Paytm per 100 रुपए प्राप्त हुए. The announcement that comes in the soundbox like thingy, where the server needs to push an event to the merchant. Okay, hey, you have received 100 rupees. That's where WebSocket is needed. Can the client poll? Yes. Even without WebSockets, this will work. But that's the fancy thing to do. Previous topics. What is hot reloading using Docker? I have no idea. What is hot reloading using Docker? Hot reloading. I know what hot reloading is. I don't know what Docker is. I don't know what. Do you mean live reloading? Oh, acha. It basically means that when you are running a React project locally, you run this. What do? You run npm run dev. And any change that you make here and save, it immediately comes to your front end. You don't have to go to localhost 3000 and refresh. वो immediately आ जाता है, right? Hot reloading using Docker basically means when you try the same thing in Docker, right? If you run a front end in Docker run, some whatever local front end. What will happen is this local front end, this will create a new container which will have a copy of all of your files. If you update anything in the IDE, if you save this save does not happen in the Docker container. So the Docker container does not know a file is changed. So your front end doesn't update. So adding hot reloading in Docker, whenever you see this issue, I'm assuming you saw this issue either in any of the repositories. Whenever you see this issue, what you have to implement is bind mounts. You have to make sure that if I make a change here in my editor, it goes to the Docker container that's running my front end. That's what it means. Suppose I push my image or Node.js to Docker Hub and I waited. If I change code, it builds image and push Docker. ये नहीं समझ आया यार. Off topic. Time to go to Max. Sounds good. Alrighty. YouTube does this next week topics, which I knew. I will try to this week, organize them first and then post them. I have nothing at the top of my head right now. Okay, Aditi asked some questions. Aditi, this page is not found. Can you make it public? Redis PubSub inspired from Backpack Codebase. That looks pretty good. Oh, I saw this. I think you sent the same on YouTube as well. That looks pretty good. Thought I start this. Let me start it. YouTube does this. Okay, same questions. How many classes left in 0 to 1? There are no official classes. There are some videos that are pending. Kaun si bachi ab? There is a list that Akash keeps sending me from time to time. Like the merchant app is probably the biggest one. There is one also called, trying different clouds. So like some low-hanging fruit that's left, but nothing major that's left in 0 to 1. Please do classes for job searching, industry, and freelancing. There's a video from Cohort 1 I'll put. Maybe one day I can just, create a random class. Will slides in this thing be valid for 2 years? They'll be valid always. It's open only. Can a person gone through 0 to 1 cohort learn Web3? Yeah, that's a great foundation for Web3 basically. Anyone can learn Web3, but if you have the 0 to 1 foundation, then it's probably the perfect stack to have under your belt before you dive in. Your views on 3JS is pretty good. I've not used this too much. I've done this once in one job, but future of WebXR, I don't know, not very bullish on it. Playing games in web environments, will this be accepted in the market? I don't know. Long story short is there aren't a lot of companies that use it. I don't think, not very bullish on games in the browsers or 3D in the browser generally. Learning questions. Is Apache Kafka a PubSub based architecture? Sort of. It gives you some extra things. It lets you create, what's it called? Skipping my head. What is it called? It lets you create. क्या है बताएगा मुझे कोई chat में? The thing you can publish, but only certain people can pick up, or certain this thing can pick up topics. It lets you create topics that certain subscribers can subscribe to. But very small. You could stake it. It's very and it also lets you replay events from a certain timestamp. Some extra things it gives you basically, but yes. In stocks like in Zerodha like stocks tab, are all stocks listed and subscribed to respective publishers? Depends on their architecture. If you open the stocks page, yeah, when you open the stocks page on Zerodha, let's say, there is a good probability if you're a subscriber, if you see 100 stocks here, you are not sending them 100 requests. Okay, yaar, please give me Apple stock. Please give me them. You are probably sending them a bulk request. Okay, hey, give me, I'm interested in Apple, Google, Nvidia. And then, the server is like, okay. And, does the same thing, publishes, subscribes to the right things, so on and so forth. But yeah. Of course, I don't know their architecture, but yeah, this is what I would assume. Okay, if you open a page, you see 100 stocks, you tell the server I'm subscribed to 100 stocks, and then whenever an update happens on the price of any of the stocks, you receive that update. How when unsubscribe is called? Yeah, so if you look at the code in the slides, what does it say? It says, whenever a user says, I don't know, I'm no longer interested in the Google stock, we check, is this stock, we remove the user, subscribe. Whenever the user says, I am not interested in Google anymore, we remove that user from that specific subscriptions. We remove, this user is no longer subscribed to Apple stock, and we check, kuch bacha hai, is anyone else left that is subscribed to the Apple stock? And if no one is, if this dot subscriptions dot get stock dot length is 0, which means no one is now interested in the Apple stock price on this server, we unsubscribe. We tell him, bro, sorry, we don't need any more future updates on the Apple stock. I have no users that are now interested in the Apple stock price. All right, let's do one more. I created a new one. I think there was some problems in the old one, right? I will not commit anything. But I will try to do reviews of, this is daily code, right? Yeah. I will try to finish all chess, then daily code reviews today. I'm not committing, but let me grab dinner and after that. Why did we send batch requests in yesterday's attacker's code to exploit Reddit instead of individual requests? Did you not see when I was trying to sending the requests? After 300,000 requests, my server ran out of memory. If you bombard the other side with a lot of requests, your Node.js process also, is maintaining those sockets, right? At some point, it will run out of memory. So that is why we bash request. कि भाई पहले 10 कर लो पूरी. अच्छा हो गई. चलो next 10 I will send. Oh, they are done. Next 10 I will send. I will only have 10 sockets open at any point. Versus, if I send all of them together, I will have 100,000 sockets open. My Node.js process will crash. So to make sure that 10 requests are done, completed, closed, we next start the next 10 requests. That's why we sort of batch them together. You can increase the batch size. We did the batch size of 100. You can do batch size of 1,000, 10,000. But at some point, you have to reach a sweet spot. I can't send more requests than these. But multiple server environment, how is this store.tsv synced? So that's the thing. What's your name? I don't see your name. Raj Saroj. If you have multiple servers and in-memory data, if this is server 1 or whatever, WS server 1, WebSocket server 1, WebSocket server 2, and both of them are chess servers, let's say, and then the first person sends an event here. Here I'm putting E4, E3, E4. This gets stored in the store.ts here. This will go to a pub sub, from which it will reach the second server, over where, it will get stored in the store over here, and then it will go to the end user. So the store over here will also incrementally update as it receives the event, not from the end user, but from the pub sub. So this update will happen in multiple places. If you are storing the chess game in multiple servers, all of them will incrementally update as the receive event from the pub sub. One of the servers will receive it from the user, the rest of them will receive it from the pub sub. Thanks for answering Singleton via Prisma. Follow up to that. If we have only one connection through which we do the database calls, if multiple people query the database, won't that create a queue, increase latency for posting data? Yeah, yes, but there are more upsides and downsides to this. Number one, you never do very sort of do. That is a good thing. You don't want anytime your end user sends you a request, you create a fresh database connection. You want to maintain a single one, and then as users come, you want to throw data there. Of course, there is the client or the database will itself throttle you if you're sending too many requests. But this is like a weird solution to the problem. Just so that I don't choke a single connection, I will create multiple connections. Never seen that happen. Theoretically sounds great. We will create 10 connections to the server. But you will anyways do that. You will anyways, when you're creating a Prisma client, I'm sure there's a way to send in some attributes that let you create multiple connections, 3, 5, 7 connections. So you probably want to do that versus what you're suggesting. Also, we have done row-based access control for users so that they can only access certain contents in CMS. Row-based access control. So yeah, it's a little weird the way we've done it in CMS. CMS has like recursive folders. Look at the schema. If in hindsight I would use like a NoSQL database there because the schema is so recursive. But yeah, just look at the code. The way we've done access control is every top level video is associated to a course. So every folder is associated to a course. Folder week 1, week 2, week 3 folder, and then whenever you open your course dashboard, we check what all purchases have you made, what all folders do you have access to, you see them. All PR reviews deferred until I have dinner, please. But I will do, at the very least, just 100% today. Daily code I will try, but most probably yes, I will do that as well. So if this isn't daily code, it'll happen today. Don't we have some data race problem if we store the data in memory? Maybe JS is single threaded, but yes, so thankfully JS is single threaded. You don't have data race problems, but again, in a multi-thread environment, you will have it. In Node.js, you won't. Let's in the real language person move simultaneously. Yeah, exactly. So this won't thankfully be a problem. Even if you are in a multi-core environment, multi-thread environment, you will keep all of the single game logic on a single thread. This game will exist only on this thread, so that to avoid race conditions like you're talking about. Second year and feeling a little semester around the corner, I would wait and then complete your semester and come back. Don't do the cohort in a very anxious state. Do it aram se, and that's when you'll extract the most outcome from it. Why does static variable have private inside the class? Why does static, you mean this? No reason. I mean, just so that people cannot do whatever pub submanager.instance. People try to do this, it sort of gives them an error. People can't update this, people can't access this. If they want to access it, they have to go through get instance. That's pretty much the reason. That's why you make anything private, right? So that people can't directly access it from outside. Any good resources to learn about JavaScript patterns? Just Google about them. The thing is, so I first create like every pattern, but then I realized you don't really use any patterns. Singleton bhi maine ghusaya hai har jagah, people rarely use any of these patterns, especially these factory patterns, adapter patterns are rarely, if at all, used in JavaScript projects or merge stack projects or Next.js projects. I've never seen them other than Singleton. I've never, and maybe Static that also I introduced in the company. Never seen patterns used, which is why I sort of avoided them. But we can talk if a lot of people need it. I'm happy to do like a class. It'll be more Java specific of a class, but yeah, we can talk. VS Code, I pushed image Node.js Docker Hub. I wanted to change the code. New image. You can repush. You can change the code. You can do a Docker push. It will change the tag. Your old image will also exist. Your new image will also. You can keep pushing updates to your, Docker image. Job guidance part 2 off topic here. Okay, 5 to 10 minutes. Oh, okay, ignore this. I want to ask. So, share the name of the company. I want to discuss more with you. I need a few minutes. Google Meet is fine. Just ping Rookie. Get my number and ping me on WhatsApp. Let's go from there. I am working on Medium clone. As I am trying to publish the NPM package, couldn't do authentication. Works fine for my backend, but I get this error. Requested module doesn't provide sign up params. I will have to look at the code. Ask a TA basically. It seems like a very problem specific to you. But yeah, it seems debuggable. If you open your code where you see this error, try to reach that file, see if the export has happened here. Point a TA to your NPM module. I think they'll be able to help you out from there. Why are we doing this? Substitution or greater than? Why do we check if it's greater than 0, right? Yes, great question. Seems like your data structures and algorithms is a little weak. Why are we doing this? Okay, if this is 1, because we don't want to resubscribe. As soon as it reaches 1, you subscribe. Uske baad if it reaches 2, 3, 4, 5, you don't care. You have subscribed once. Then unsubscribe happens at 0. Subscribe happens at 1. Unsubscribe happens at 0. Can you keep resending it? Sure. If it's greater than 0, keep resending it. You don't really need to send it again and again. You tell the pub sub once, कि यार एक बंदा तो आ गया. Now I need every future event on Apple for you. Until the number reaches 0. Cool. I think we'll call it here. Thank you, everyone. Or unless there are more questions, there are more questions. All right. Last set of questions, then we'll call it, guys. How to check if my node server is about getting overloaded and spread a new server? Just look at the CPU usage, right? Whatever your server is, wherever you deployed it, AWS, GCP, put up alerts. Care if it reaches 50%, alert me. You can also put up strategies like keep the average CPU below 50%. So as soon as it goes over 50%, it'll spin up a new server. Read about auto scaling groups in AWS. I'm new to open source contribution. Recently, I've set up the daily code and started understanding the repository and made small investments. Issue, can you review this? And should I raise a PR? Let's look at the issue. Now, what is the issue? 321. Oh, there's a dot. Adding light and extra code blocks. That is a great issue. I am happy to assign it to you. This doesn't look very good though. Whoever added this also I don't like. I don't love how this looks. I'm happy to assign this to you, but make the code blocks a little cleaner. But yeah, I don't know actually this is needed. I think even people, I don't know. I'm okay. Created, worst case doesn't get merged, but even people who use light mode like to look at their code in dark mode. Maybe I'm assuming too much here. Mukesh, I like the idea. Technologically, the Pebble leverages modern tool framework. अरे बाबा ये ChatGPT से लिखवाया क्या? भाई ये तो पक्का ChatGPT से लिखवाया तुमने. But I like the idea. Two people competing on an algorithmic problem sounds pretty good. I worked in 2 startups. I don't have the foreign constraint on the table. They have just added corresponding columns and reference the table, but not at any constraints. When should we add hard constraint? I think so. In startups, you don't even keep track of indexing and foreign key constraints, which is fine. You should add them generally, but you don't care about this in startups. You're like, koi baat nahi, hum galti karenge nahi. We will not add an entry that doesn't refer. But usually you should have that. You should always have that. There is no when. You should always have it there. Also, when should we use ORM? When should we use raw queries? There is no good answer here. It's just, if it makes your life easy, use an ORM. If you want to switch from SQL to MongoDB in the future, you might have to switch, then use an ORM because it makes it very easy to switch from one DB to another. If you are if you want to own, there's no good reason to write SQL queries ever. But there are a few inconsistencies in Prisma. Prisma doesn't let you do joins a certain way, but it lets you send raw queries. So you can always use Prisma and send raw queries. Referral request. My phone was saying it is. When you're using Redis Game Manager, is it async when calling the methods async and await construct needed for normal Game Manager? If a client using Game Manager does require, how when you use Redis Game Manager, it is an async task when calling methods async and await construct is needed, but not for normal Game Manager. Therefore, client using Game Manager does require, okay, I guess you're saying, okay, you have to update all the function calls because now you will have to await them when you're using Redis versus if you're using it in memory, this thing, you don't have to. Yeah, that is true. There is, what you can do is you can always keep the sets async even if they're not async, as in, even if you're only doing Synchronous operations, you can still put an async in front of the function and call await everywhere. It won't do anything, as in you don't really need to await anything in case of an in-memory database. But that can get away from your problem that you're talking about. You know, you don't have to change the code everywhere. All right, guys, I'll call it here. I think a bunch of PRs, which I'm going to almost 90% look at. And I'm 100% going to look at. The question is, do I look at them on a stream or, you know, in my own time? That is not sure, but 90% let's do a stream either on YouTube or otherwise, and, you know, review some pull requests. So with that, let's end it, guys. I'll see you guys next week. Bye bye.